memory and pointers in C programming language from Headfirst C book. And in the last time in the stream, we discussed a bit complex things about memory and pointers, about arrays, how arrays are related to pointers in memory. And let's try to go through once again what we gathered, what sort of information we gathered in the last time. So let's create a file revise.c, and here so hash include stdlib.h, hash include stdio.h, and then we will create our main function. And then we will try to understand the difference between character array. So for example, if we are defining an array of characters and defining and providing a value to it, so for example poor, okay, and then we will try to print this value. And sorry, I have to open my tmux device.c. So here, if I'm going to execute this program now, so it will print poor. That is fine. That is what we understood. Similarly, if there is another way to define a character of arrays, and that is using pointers. So let's assume we take a pointer to a character, and name it last, and then the last is coders. Right now we want to print it. We can also pass last to, or okay. Now let's run it. So poor coders. This is also fine. This is also fine. What is the difference between both of them? The difference between both of them is this is stored in, as we know, constant memory block. Constant memory block. And this is stored in, I think it is getting stored in stack. So this is the difference. This cannot be changed, but this can be changed. So let's try to change it. For example, am I going to change array 0 equal to p rather than p? We will update to s. Now s will not be fine. T, okay, T will be fine. Then we are going to print it, and it will print TOOR. TOOR. Then what if I try to update now last, and how we are going to basically refer that place in memory? There are multiple ways. So what we can do like this: last value at last. No, this is not so. Value at last equal to, one mistake which I did was it is single quote because it is a character. Value at last is, let's assume, coders. Either we can do it this way, or we can simply do it this way. Last 0 equal to b. So both are similar, and then we will try to print it last. So will it get executed? The first one will get executed, will get compiled, but first one will get executed, the second one will not get executed. Segmentation called code dump, because this is in the constant memory block and this cannot be changed. Even if we try to do it like this, I think it will not work. Segmentation fault code dump, because this cannot be changed. Apart from that, what we learn is that we can also take input from the user via stdin, but there are different methods, scanf and fgets. But scanf was not safe because you have to mention you don't know how much data will the user input into your stdin standard input, and that would call a memory override. So rather than using stdin, we can use fgets. So we will put what is your name, and then we will create an array of name, and here we will define the size. And what will be the size of, so example 10. 10 will be the maximum. Then fgets, and then we will print that the buffer in which you want to read the value. So name, will automatically pass the address of the first What is happening when you define a character of name? Name is an array of characters, and it automatically, when you try to point a name, so what name does is name is equal to value address of name 0. It is actually like this. So it stores the address of the first character. So we don't have to specify it. So we don't have to specify it manually, and then you have to enter number of characters you want to be take input from user, including the sentinel character. So what you can mention is 9. Then mm, then you have to enter the, what do we say, what do we call it, stdin. I don't remember what do we call it, but it is like a sort of a reader where you want to read the value from. So if we compile it, I'm sorry, on the this we have to delete. We will compile it, or we will execute it. What is your name? 3. So we didn't print this value. So what we can do, print your name is percentage comma, and we will pass the address of the first place. It will automatically try to read until /os encounters. Okay. The name is clear. Got it? So it is clear. Okay, so this was a simple what we covered in the last. What we covered in the last session. So today we will now continue with the next thing. It is the same thing when we are trying to when we are using. So if the computer loads the string literal, as before, when the computer loads a program in memory, it stores the constant values like j, q, k into read-only memory. That is a constant memory. The program creates a new array when we use array of characters. While we are declaring an array, so the program will create one large enough to store j, q, k string 4 characters for in the stack, and that can be updated. The program initializes the array, but as well as allocating the space, the program will also copy the contents of the string literal jqk into the stack memory. That is fine. So the difference is that the original code uses a pointer to point to a read-only string literal. It is saying that when we try to copy, so this code, we can create an array of characters, and then these two functions are equivalent. As last time we have discussed that. But if cards is being declared a function or argument, it means that cards is a pointer as we are using it. This is also we covered last time, and both these are equivalent. So the difference is that original code uses a pointer to point to a read-only string literal, but if you initialize an array with a string literal, you then have a copy of the letters, so and you can change them as much as you like. So the original code uses a pointer to point to read-only string literal, but if you initialize an array with a string literal, then you have a copy of the letters and you can change them as much as you can. So when what is it is trying to when we initialize an array with a string literal, then we have a copy of the letters, and so you can change them as much as you can. So we can find it. Now cards equal to a cards equal to cards to happens. Now we are doing it. Now we are not using a pointer. So earlier why it failed, because here we used a pointer. Rather than creating array, we use a pointer, so it did not work. But now we are using a cards array. So here a card equal to cards2. So it is a character and card 2012. So this will contain K. A underscore C for card will contain K. Okay. Now second line. Card 2 equal to card 1. Card 2 equal to card 1. Now card 2 equal to cards 1 and cards 1 is Q. Okay, so that means now it will be JQQ. Okay, now they are saying card 1 equal to card 0 and card 0 is J, and now J J Q. Okay, now card 0 equal to card 2, card 2 and card 2 is Q. So it is QJQ. Okay, and now cards 2 equal to cards 1, cards 2 equal to cards 1, cards 1 is 01J, so it is QJJ. Now it is saying cards 1 equal to A card, cards 01 equal to A card, and A card was QKJ. This was our output, and it will print that. So your card variable now points to a string in an unprotected section of memory, so we are free to modify its content. One way to avoid problems in future is to never write code that sets a simple character pointer to a string literal value that like this. So never write this code. Never ever write this code. There's nothing wrong setting a pointer to a string literal. The problem only happens when you try to modify a string literal. Instead, if you want to set a pointer to a literal, always make sure that you use the constant keyword so that anyone who is reading the code, anyone who is reading a good code is able to understand that it is a constant. It will never get updated. That way, if the compiler sees some code that tries to set the modifier string, it will give you a compiler. Okay, so it is clear. The case of Magic Bullet. He was scanning his back catalog of guns, ammo into delicious library when there was a knock at the door and she walked into 5'6" blonde with a good laptop and a cheap shoes. He could tell she was a code jockey. You have gotta help me. You gotta clear his name. Jimmy was innocent. I tell you, innocent. He passed her a tissue to wipe the tears from her baby blue and led her to a seat. It was an old story. She had met a guy who knew a guy. Jimmy Bromstein worked tables at the local Starbucks and spent his weekend cycling and working on his taxidermy collection. He hoped one day to save up enough for an elephant, but he had fallen in the wrong crowd. The masked trader had met Jimmy in the morning for coffee and they had both been alive. So a masked trader, which is a character of Gary, alive, and which is a string literal masked trader. So what we are doing is we are creating a string literal masked trader. So we can understand here. So what it is saying that Jimmy is a pointer to an array of Jimmy is a pointer to a character, and that means Jimmy will store an address of a character. And what does it return? It returns the address of the first character. Okay. Masked trader is percentage. Jimmy is percentage. Masked trader Jimmy. So it will print alive. Masked trader is alive. Jimmy is alive. Okay. Then that afternoon, the masked trader had gone off to pull a heist, like 100 heists he had pulled off. But this time he hadn't reckoned on the crowd of G-men enjoying their weekly 3-card Monte session in the back room of the head first lounge. You get the picture. A rattle of gunfire scream and moments later the villain was lying on the sidewalk creating a public health hazard. So masked trader 0 equal to D, masked trader 1 equal to E, masked trader 2 equal to A, masked trader 3 equal to 10, and masked trader 4 equal to exclamation. So now the problem is when Toots here go to check in with her boyfriend at the coffee shop, she told he served his lost orange, mocha frappuccino, and printf master is percentage, Jimmy's percentage, master and Jimmy. So mask reader's address has been changed, and so automatically Jimmy's the address where Jimmy was pointing it also get changed. What do you think had happened? So we will try to understand how it happened, because it is clear. So rather than going like it is, we will change of it. Okay, and we will create a method again, and then here what we will do is we will try to create a character of array. What do we call it? Let's also name it Jimmy. Equal to, and we will set it to alive. Okay, that is fine. Then what we are trying to do is we are creating a done. And pointer to mask, pointer to data, that is one data equal to which will contain 0. So that is fine. Now if we are going to printf Jimmy is percent s, comma reader is percent s backslash backslash, and we will write Jimmy comma read gcs drops. Jimmy is alive, reader is alive. So that is fine. Now if we try to understand, let's add this one. Puts. Then what we will do, print address location of first element in Jimmy is percent p, comma, and reader and reader is percent p, comma. So if we try to find the first location of Jimmy and data, this is the first location. Okay, and what we will do is Jimmy 0 equal to D. Right? Then we will yank it and we will paste it here. Now rather than first element, what we will do, we will try to print the second. Okay, and here Jimmy, we will do Jimmy plus 1, and Trader, we will do Trader plus 1. Fine, and then we will do Jimmy 1 equal to E. Paste, and we will paste it. Second, after second, we will do third, and then we will do third, and we will do, oh my god, sorry. I think I have opened an older section. Sorry, so everything we wrote got deleted because I was not able to save it. So let's again do the and okay. Then rather than first, I'm going to change to the second element, then third element, and then fourth element, and then for Jimmy, I'm going to increase the address to 1. Increase the address to 1. Then here also I'm going to increase the address by 2. Or by 2. And here I'm going to increase the address, increment the address by 3. And what we will do here is D, A, and it is D. And here now what we can do is we can print whether Jimmy is alive or not. Now first we will compile it as we all know. Now we will run change. So you can see is E. Oh, it was forward, so last one was also there. The location of first element is of in Jimmy is this, and the location and radar is also same. So you are seeing that both of these are pointing to the same address. That's why when we are changing the value at the address stored by the Jimmy, it is getting automatically changed in the radar also. Because radar was pointing to the radar was nothing. Radar was just pointing to the location of the first element in the Jimmy array. So then if we are going to change anything in Jimmy, radar will also get impacted. If we are going to change anything in radar memory, Jimmy is also getting impacted. This is what they are trying to make us understand. And now these are some bullet points. If you see a star in a variable declaration, it means the variable will be a pointer. Pointer to a, pointer to a, pointer to character, pointer to integer. Most important point. String literal are stored in read-only memory. Another most important part. So if you want to declare a string, just use constant. If you want to modify a string, you need to make it a copy in a new array. You can declare a char pointer as constant char pointer to prevent the code from using a modifying string. Absolutely clear. Memory memorizer. Now let's try to understand C, stack, heap, global, and constants. Stack. This is a section of memory used for local variable storage. Every time you call a function, all of the function local variables get created on stack. It is called stack because it is like a stack of plates. Variable gets added to the stack when you enter a function, and then get taken off the stack when you leave. Weird thing is this stack actually grows upside down. It starts at the top of the memory and grows downwards. Beautiful explanation. Change its color, make it red. Very important. This section of memory we haven't really used. This memory, the heap, is for the dynamic memory. Pieces of data that get created when the program is running and then hang around a long time. You will see later in the book how you will use heap. Okay, not a problem. Globals. A global variable is a variable that lives outside of all of the function and is visible to all of them. Globals get created when your program first runs, and you can update them freely, but that's unlike constant, which we already see, are also created when the program first runs, but they are stored in a read-only memory. Constants are things like string literal that you will need when the program is running, but you will never want them to change. This is also important. Keep the color, let's do it yellow because it is not. Code. Finally, the code segment. A lot of operating system plays the code right down in the lowest memory address. The code segment is also read-only. This is the part of the memory where the actual assembled code gets loaded. Okay, so we are able to understand %, ints, return, pointer, local variable, string literal, character pointer, copy, content, variable, fgets, buff sizes. Now we are moving to string theory. We will try to understand strings better in C programming language. You have seen how strings in C are actually character arrays, but what does C allow you to do with them? That's where string.h comes in. Okay, is a part of C standard library that's dedicated to string manipulation. Great. If you want to concatenate, like in other programming languages, there are a lot of libraries. If you want to concatenate strings together, copy one string to another, or compare two strings, the functions in string.h are there to help. In this chapter, you will see how to create array of strings and then take a closer look at how to search within strings using str function. So we are going to now get closer into the string section. Desperately seeking Frank. There are so many tracks on the retro jukebox that people can't find the music they are looking for. To help the customers, the guys in the headphones want you to write another program. This is a track list. So we want to store all these tracks into an array, and then we are to find they are going to mention as a track, and we are going to store where the track is. Create an array of arrays. Okay. There are several track names, but you need to remember because you can record several things at once. But remember, each string is itself an array. That means you need to create an array of arrays like this. Obviously, earlier what we were doing. Okay. So create a function. Now earlier what we were doing, we were creating simple character name, and that will store some string. Hello. That will store it. But this is not the case. Now we are trying to store some records. Okay, and that will contain a, we don't know how many rows are there, but we know that each row must not contain more than 80 characters. Okay, so how we are going to define an array like this? So first will be track, which is in track, anything track 1 comma track 2 comma track 3, more than submit. Yes, so now we have different tracks. So there are 3 rows, this value will be 3, and each must not contain more than 80 characters. The first set of brackets for the array of all strings. The second set of bracket is used for each individual string. You may note that the track name will not get longer than 79 characters, so set the value to 80. The compiler can tell that you have 5 strings, so you don't need to a number between those brackets because we have assigned the value at that specific amount of time. Each string is an array, so this is called array of arrays. The array of arrays looks something like this in memory. Let's try to understand. I left my heart in Harvard New School. Okay. So 80 characters will be allocated like this. Then next 80 characters will be allocated. Then next 80 characters will be included, and the last set will be covered by sentinel characters. So it is important to note here the last memory spaces which are not covered will get which are not there will get covered by sentinel characters. Track 4 6 will return R. This means that you will be able to find an individual track in that list, track 4. So okay, let's try it out. Oops. Records and 01. Let's see. Oh, so GC, STR, C, STR. So it throws an error. Acha, stdio. You can see that we are directly able to access the row using the index of that specific row, record 0. So if we try to understand now what rather than going to the book, if we try to understand what will happen if we rather than, so what we are trying to do is we will give record 0. Okay, so it will definitely print the first track 1. So rather than doing this, what if we do if we only do this records? Because what it is a pointer. It is automatically matched to record 0. This is similar to value at records. Okay, so it will automatically take the first address and try to go through until the sentinel character is found. But I am not assuming this will work. So this will not work because it is actually not a simple pointer. It contains 2 pointers. So what if we do something like this? Now compile and now let's run this track 1. Okay, so you got my point. So the traversal, so that if we try to understand how the traversal is happening. Earlier what we were doing, let's try to understand again. So there are two. First is name, second is records. Okay, so if we try to put only name, it will print the name. Okay, and if we try to print here the value at name, so it will only print h. I don't think it will even work. So what we can do here is print f %c comma back %c backslash m comma, and we will value at name. Then it will print only the first. That is fine. Now, but here, so it is not like it is not like something a single pointer to an array, but it is a pointer to an array of arrays. It is not a single array; it is array of arrays. So if we want to get the pointer that contains the first memory address, we have to do it like this. Or what I think is, if we want to store 80, this will also work. But this will also work. How it works? Because earlier, if you have to define, so this defines the size of a single character of array of characters. But this no doubt I'm able to understand, but how can I explain this? Let's try to understand. So earlier, what we have an array of memory addresses characters. So for example, this one block contains 1, 2, 3, 4, 5, 6, 7. Okay, so this is our array initially. And what we were trying to do is we were storing or character of array, whatever you want to do. We were storing it inside ARR that will point to first one. Let's show that as our first one. First. Okay. Now what we are trying to do? Well, now we are not storing single dimension. We have something like this then 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. This is our array now, two-dimensional array. And what we don't know or what we don't care about is the length of each row. No, what we don't care about is total number of rows. We have no idea about how many total number of rows are. What we only know is that each specific row contains 5 elements. So how can we define it? Yeah. Now ARR equal to address of this specific first whole first row rather than the first element. How we will store the row. So earlier we were defining string as pointer to character. Now we are defining pointer to name of arrays, and each array must be length of this. So it is a pointer to a pointer sort of. Okay. Awesome. Currently, we are defining it like this. And rather than pointing to this, maybe pointer to record. And if we do pointer to record, what it will print? We can't do this because it has no centillion character, and we can do like pointer to record. It will print the first element. And how we can try to fetch the second element. So let's try to fetch the uh, second element. No, second element name. 1, 2, 2, 3, 4, 5, 6. 6 element of first track, then 6 element of second. So if we try to understand the pointer, now what we are trying to do is records. Okay, then plus. This is a little bit confusing. So if we do records, we do start records, it will give us the first. So we will increment it by 1. No, it will give us only the first element. Then whatever will it be, we will increment it by 6. So whatever will the value of records will be. Oh, okay. No, this is not correct. This is not correct. So whatever the value at, so first we want to get the address of the first element. It will get the address of the first. A bit confusing. What? Hmm. Plus 6. 1. So you can see what happened. So this record, it will give us the pointer to record. It will give us the address of this. Then we increment it by 6, and it gives us the address of 1. Now what we want is, we want this element. So this element. Okay. So what we will do is records plus 1, and then give us the address of that specific address. So first record plus 1. Record will give us the address of this. Then we will do record plus 1. It will give us the address of this. Then we will try to add the star to it. So value, this will give us the address of this. Then we increment it to 6. This will give us the address of 2. And then it will print the value of here. This will print 2. Understood? We don't increment. We don't increment. This will give us the address of record. Record gives us the address of this row, and then we will use pointer, which will give us the address of this. Then we will increment it to 6. This will give the address of this. Then we use the pointer. In order to understand, let's write it down here. records will give us the address of first row. Got it? Then records will give us the address of first element. The first element in first row. Then records plus 6 will give us the address of seventh element in the first row. Okay. Now we paste it. Record record records will give us the address of first row, and records plus 1 will give us the address of second row, and value add records plus 1 will give us the address of first element in second row, and then pointer to records plus y plus 6 will give us the address of sixth element, sorry, seventh element in second row, and then pointer to records plus 1 plus 6 will give us value of 7 really in second. Got it. So it is clear now what is happening. Okay, and this is also clear. Track 0, we can directly print that. Apart from that, we can also use, so this is somewhat similar to, if we try to understand printf %c backslash n comma records and the first element and the sixth. Okay. This is also similar. 1 1 2. Okay, both are similar. Reversing the array. Find strings containing the search text. Now let's try to. The guys have helpfully given you a spec. Well, you know how to record the tracks. You also know how to read the value of an individual track name. So it shouldn't be difficult to look through each of them. But you even know how to ask the user for a piece of text to search for fkets. But how do you look to see if the track name contains a given piece of text? Using string.h. The C standard library is a bunch of useful code that you get for free when you install a C compiler. The library code does useful stuff like opening files or doing math and managing whole memory. Oh, I don't understand why it is not working. I have been trying to debug it. I can go offline and then try it again. But the point here is, if we are going to define it, the exp, if we are going to define this code here, we'll only call the jukebox. Okay. Then if we run this code, that you that enter the track we want to search for, poor, not found. Okay. So there is some issue, but if rather than going through this, we are creating a simple array and coders, and here rather than using expected value from the user, we are going to use it directly coders. It is able to find it. So the problem here is, if we are trying to read the value from the std, it is not able to understand it. But even if, I don't know why it is happening, but if we put that exp, we print the correct value. Coders will print that. Print that. Print that coders. The space. Where does it come from? Okay. This 18 pointer. Pointer. Exp. First element. Oh, okay. I got it. I think it also contains the backslash zeros that are being appended to that specific coders. So that is the problem. That is the problem. So if we keep it 80 and put a COTERS 6, coders function is track for coders. Now it won't, because there was, if we are using 80 here, then we are going to append backslash zeros also, and that backslash zeros is causing problems. So if we try to search for thin zero, see, so that is a disadvantage, but we can't say disadvantage, but we know we are expected the name of the track to be of 80 characters. So this is causing the actual problem. But the point is, if we are using that 80 here also, so backslash it must get appended here also. But it is not that case. Apart from that, every code of ours is same. So we can't use 80 here. That is it. We are LENS. So we can find the length also. Size t. Size t is just an integer during the Form string is coolers, but what if I do it with 80 coolers? No point. No point. Because due to size. It is 80, 80 including 17 is left as also. Same could I have written which they are used. Yesterday. Okay, so I think this is enough for today. We were able to debug this issue. This will not work. I think for if we execute it, orders it will work. But for poor, it will not work. Definitely. Rows are extra back by zeros or 22. We have to find solution to this problem. Okay. So I think that was enough for today. Thank you for bearing with me. Thanks.